Hello everybody, my name is Matthias Deeg. Welcome to my talk, There is Always One More Bug or More, Revisiting a Wireless Alarm System at Hacktivity 2020 Online Edition. As the title of this talk suggests, there is still one more bug to be found, or at least this is often humorously attributed to various IT products, no matter whether they are soft, firm or hardware, by people dealing with them. Within the next couple of minutes, I want to show that this assumption is sometimes very true, using the example of a wireless alarm system and some of its accessories, in which yet another security vulnerability could be found over the past few years more than once. But before we get to interesting things, let me briefly introduce myself. As mentioned before, my name is Matthias Deeg and I've been working as an IT security consultant for the German IT security company SÜSS since 2007. I'm also head of research and development and in charge of our responsible disclosure program regarding security vulnerabilities. I've been interested in information technology since my early days and very curious, in general, whether security assumptions in soft, firm or hardware hold true when taking a closer look. The agenda for this talk is as follows. First, I'm going to give a very short introduction to the used technology of the tested target device, an ABUS Sequest wireless alarm system and some of its accessories. Then I want to give an overview of our research, the used test methodology and the involved people. In the last few years, there has also been published research on wireless alarm systems by other researchers that I want to mention. Next, I'm going to talk about the attack surface and attack scenarios which are relevant for a wireless alarm system. Then I want to present the actual security vulnerabilities of our research that we have found and reported. And for most of them, I have also prepared short demos. Finally, I'm going to draw some conclusions and want to give some recommendations concerning wireless alarm systems. And at the end of my talk, we have some time for Q&A. Here you can see the main target device of this presentation, an ABUS Sequest wireless alarm system and some of its accessories, a wireless motion detector, a wireless remote control and a proximity chip key. Later on, you will also see two more components for the ABUS Sequest wireless alarm system not shown here, namely a wireless control device and a hybrid module. As the word wireless in wireless alarm system implies, the different components are using radio technology for communication purposes. All accessories besides the proximity chip key use radio communication in the 863 to 870 MHz frequency band on 868.6625 MHz. The RFID communication of the proximity key is in the 13.56 MHz frequency range. On this slide, you can see a top view of the ABUS Sequest main panel's PCB with an ARM-based ST Microelectronics microcontroller and a flash memory chip. For conducting security analysis of the wireless alarm system and performing actual attacks, the software-defined radio Hacker F1 and the radio dongle Yardstick 1, both by Great Scott Gadgets, were used. In my experience, these two radio hacking tools work reliably and are good enough, at least for my needs. The Hacker F1 is supported by most SDR software tools, for instance GNU Radio Companion or Universal Radio Hacker. The Yardstick 1 makes use of the quite popular sub-1 GHz transceiver CC1111 by Texas Instruments and comes with the RFCAT firmware installed. Another tool used during this research project is the Erica Neighbor developed by Thomas Dietert for the GreatFat1. This device provides 4 Texas Instruments CC1101 transceivers that can be tuned for different frequency bands, namely 315, 433, 868 or 915 MHz. The proper configuration of 2 transceivers per frequency band allows for short reaction times required in specific test cases, for instance concerning reactive jamming attacks, as you will see later. Besides the presented test equipment, some experiments and proof-of-concept attacks were also implemented on a Teensy development board with a corresponding CC1101 module or on another device with a cool form factor that you will see in one of the demos. Two important technical facts about the wireless communication of the ABUS Sequest wireless alarm system and its components are that differential Manchester encoding is used and that the integrity of radio packets is checked via a 16-bit CRC. Our research of wireless alarm systems actually started back in 2016 when my colleague Gerhard Klostermeier and I decided to analyze different, mostly low-cost wireless alarm systems for the simplest radio-based attack, the replay attack. The discount store Aldi on the opposite side of the street back then was selling a quite affordable wireless alarm system set named Easy Home, which started this research project in which we tested several wireless alarm systems by different manufacturers. The ABUS Sequest wireless alarm system happened to be the most expensive of our test devices. Our main test result back then was that all tested wireless alarm systems were vulnerable to a simple replay attack. And to be honest, I was surprised by this a little bit, because I had assumed that a security product like an alarm system offers better protection. In autumn 2016, we published our findings on German television in the TV show Plus Minus and raised the security awareness for this kind of security issue. The ABUS Sequest wireless alarm system that we had bought was still available after this research project for further tests, but at first was stowed away in our lab. Sometime later, we got a tip by Thomas Detert that the security fix for our reported replay vulnerability introduced new security vulnerabilities in the ABUS Sequest wireless alarm system. Thus, with external support, first by Thomas Detert and later on also by Michael Rüttgers, we had some further looks at the ABUS Sequest wireless alarm system and found some more security vulnerabilities within the last 2 years, which we have reported to ABUS in the course of our responsible disclosure program. When analyzing the wireless alarm systems, we actually did not follow our usual 3-part test methodology for radio-based devices, including a hardware analysis, a radio-based analysis, and firmware analysis, but this time we only used the radio-based analysis. Fortunately, this was enough to find some security vulnerabilities. As with almost every topic, there is previous research. On this slide, I have listed several other publications regarding the security of wireless alarm systems, which has been released within the last couple of years and that I am aware of. So hacking wireless alarm systems is anything but new, but I hope that with our latest research I'm presenting here, I can add some interesting material to this topic. Concerning the attack surface of wireless alarm systems and different relevant attack scenarios, there is not that much to consider in my opinion. Attacks requiring direct physical hardware access are less interesting, and attacks that can be performed via radio signals from some safe distance, only requiring physical proximity to the target device, are more interesting. Different kinds of attacks against radio-based systems that come to mind are replay attacks, brute force attacks, denial of service attacks, jamming attacks, sniffing attacks, spoofing attacks, and cloning attacks. The last one referring to RFID communication. Here you can see an overview of the 8 security vulnerabilities we have found regarding the ABUS Sequest wireless alarm system and some of its accessories. The first security issue I want to talk about is simple replay attacks. For exploiting this security vulnerability, an attacker just has to record an interesting radio signal, for example a disarm signal for deactivating the wireless alarm system, and to replay it later at the right moment. When proprietary radio protocols are used in wireless devices, they are often missing a replay protection or only have an insufficient one. As mentioned earlier, all wireless alarm systems that we have tested back in 2016 were vulnerable to simple replay attacks. This kind of attack enables an attacker to deactivate an affected wireless alarm system in an unauthorized manner. In 2016, we exemplarily demonstrated such a simple replay attack in the German TV show Plus Minus. On this slide you can see the probably most simple flow graph for GNU Radio Companion, which we used for our replay attacks. The second type of attack I want to present here is a rolling code attack. In order to fix the replay security vulnerability we had reported, Arbus implemented a rolling code in your remote controls of the Arbus Sequest wireless alarm system and claimed to use secure wireless communication now, as you can see on the corresponding product website. But as Thomas Detert found out, the chosen rolling code implementation was cryptographically weak. It was actually so cryptographically weak that by observing the unencrypted radio signals, it was possible to deduce the used rolling code algorithm. And by knowing the rolling code algorithm and its current state, an attacker can deactivate the wireless alarm system in an unauthorized way, or perform a denial of service attack against the wireless remote control by desynchronizing it. In the next demo, I want to demonstrate a successful rolling code attack. Our test setup consists of 3 parts: an Arbus Sequest wireless alarm system, an Arbus Sequest wireless motion detector, and an Arbus Sequest wireless remote control. Let's see if our test setup is working properly. Sounds good.
Die Alarmanlage ist deaktiviert. Achtung! Ein Einbruchsalarm wurde ausgelöst. Rückstellung ist notwendig.
An alarm was triggered, thus we have to manually reset the wireless alarm system.
Hat die Rückstellung durchgeführt.
With the configured wireless remote control, the wireless alarm system can be conveniently armed or disarmed.
Die Alarmanlage wird aktiviert.
The activation was successful.
Die Alarmanlage ist deaktiviert.
The deactivation also worked as intended. Now it's time for our proof of concept attack. The attacker listens for an alarm signal to learn the current rolling code state,
Die Alarmanlage wird aktiviert.
and later sends a disarm signal with a correct rolling code.
Die Alarmanlage ist deaktiviert.
The predictable rolling codes enable an attacker to successfully deactivate the wireless alarm system in an unauthorized manner. As a matter of fact, now no alarm is triggered. We have also developed a Python proof of concept tool using a yardstick 1.
Die Alarmanlage wird aktiviert. Die Alarmanlage ist deaktiviert.
The unauthorized deactivation of the wireless alarm system worked as expected. Another proof of concept tool using 18Z 3.2 with a CC1101 module was developed by Thomas Detert, who found the security vulnerability. For demonstration purposes, this proof of concept implementation automatically deactivates the wireless alarm system after a couple of seconds.
Die Alarmanlage ist deaktiviert.
The third type of attack I want to show you is a proximity key cloning attack. The Arbus Sequest wireless alarm system supports so-called proximity chip keys. Unfortunately, the insecure RFID technology MyFair Classic is used for those proximity keys. Thus, an attacker with one-time access can easily read the information stored on such a proximity key in a very short time from distances up to 1 meter, depending on the used RFID reader. This allows for simple cloning an Arbus Sequest proximity chip key and deactivating an affected wireless alarm system in an unauthorized manner. In the next demo, a successful proximity key cloning attack is demonstrated. Our test setup consists of 3 parts: an ABUS Sequest wireless alarm system, an ABUS Sequest wireless motion detector, and an ABUS Sequest proximity key. Let's see if our test setup is working properly.
Die Alarmanlage wird aktiviert.
Sounds good.
Die Alarmanlage ist deaktiviert. Achtung! Ein Einbruchsalarm wurde ausgelöst. Rückstellung ist notwendig.
An alarm was triggered, thus we have to manually reset the wireless alarm system.
Die Alarmanlage hat die Rückstellung durchgeführt. Die Alarmanlage wird aktiviert.
Now it's time for our proximity key cloning proof of concept attack using a handy pocket computer, also known as smartphone. First, we use the Android app My Fair Classic tool by Gerhard Klostermeier to read the contents of the ABUS Sequest proximity key. Then we use a somewhat special blank My Fair Classic card and write the previously read contents to it. We enable an advanced feature to also write the manufacturer block and write all sectors, although in this case it would be sufficient to only write block 0 of sector 0 containing the device UID. Now we should be good to deactivate the wireless alarm system with our cloned proximity key.
Die Alarmanlage ist deaktiviert.
Success! We disarmed the wireless alarm system with a cloned RFID token in an unauthorized way. As a matter of fact, no alarm is triggered now. For RFID and NFC security tests and demonstration purposes, there are also other great tools available.
Die Alarmanlage wird aktiviert.
For example, the Chameleon Mini, which is a versatile NFC device with a cool form factor. Programmed correctly,
Die Alarmanlage ist deaktiviert.
it can also serve as a proximity key for the ABUS Sequest wireless alarm system. Last but not least, I want to demonstrate a third way to perform a simple RFID cloning attack.
Die Alarmanlage wird aktiviert.
This time, I want to use this blue My Fair Classic RFID token in order to deactivate our wireless alarm system. Now it doesn't work. But this very user-friendly device from China can help us with that.
IC card.
First, we read the content of the original ABUS
Read
Sequest
success.
proximity key.
Card number is 142511725.
Then we write it to our blue RFID token.
Write success.
Let's see if the cloned RFID token works as good as the original one.
Die Alarmanlage ist deaktiviert.
Success! We disarmed the wireless alarm system with a cloned RFID token in an unauthorized way once again. The fourth radio-based attack I want to talk about is a so-called reactive jamming attack. The ABUS SegWest wireless alarm system has an RF jamming detection, which can be configured to trigger an alarm if there are unusual interferences on the used radio channel. However, Thomas Detert found out that the implemented RF jamming detection is insufficient, as short jamming signals are not detected and won't trigger an alarm. Therefore, an attacker is able to perform a reactive jamming attack. The idea of radio jamming attacks in general is to exploit the used shared medium of wireless transmissions, the electromagnetic spectrum. In order to disrupt a targeted radio transmission using a specific wavelength, an attacker simply transmits his own radio signal interfering with the original one. This results in the intended receiver of the radio transmission not being able to correctly receive the original signal anymore. Reactive jamming means that an attacker reacts to specific wireless transmissions and only tries to disrupt those. For this, the start of an RF message of a wireless alarm system component, for instance a motion detector, has to be detected, and quickly after this event, a stronger attacker-controlled signal has to be sent. By performing a successful reactive jamming attack, it is possible to suppress correctly received RF messages of the wireless alarm system in an unauthorized manner, for instance to prevent alarms. On this slide, overlaying an original signal with a stronger attacker signal during a reactive jamming attack is illustrated. In the following demo, I will show a successful reactive jamming attack. Here you can see the used test setup with an ABUS SegWest wireless alarm system, a wireless motion detector, and the GrateFed 1 with the Erica neighbor connected to the attacker system. First, let's activate the wireless alarm system and see if an alarm is triggered via the motion detector. As you can hear, the test setup works fine. We reset the wireless alarm system and activate it again.
Achtung, ein Einbruchsalarm wurde ausgelöst. Rückstellung ist notwendig. Die Alarmanlage hat die Rückstellung durchgeführt. Die Alarmanlage wird aktiviert.
Now, we start the reactive jamming attack using our developed software tool, Reactive Jammer. While the Reactive Jammer is running, it detects wireless transmissions of all components of the ABUS SegWest wireless alarm system, for instance the wireless motion detector, and overlays it with another stronger signal. Thus, the receiver, in this case the alarm panel, is not able to properly decode the original transmitted message and no alarm is triggered. Furthermore, our reactive jamming attack did not trigger the jamming protection of the ABUS SegWest wireless alarm system. The fifth type of attack I want to present is a sniffing attack. The targeted device in this attack is an ABUS SegWest wireless control device you can see here. ABUS claims on its product website that this device also uses secure wireless communication. But Michael Rüttgers and Thomas Detert found out that the used wireless communication of the wireless control device is not so secure as it is missing encryption. Hence, by simply observing the corresponding radio signals, it is possible to see all transmitted sensitive data as clear text. This enables an attacker to gain access to sensitive data like PIN codes and proximity token IDs and to deactivate the wireless alarm system in an unauthorized way once again. In the next demo, successful sniffing attacks against the ABUS SegWest wireless control device are demonstrated. Here you can see the used test setup with an ABUS SegWest wireless alarm system, a wireless motion detector, the wireless control device, and a Yardstick 1 connected to the attacker system. In order to eavesdrop on the wireless communication of the alarm system, the attacker simply starts our developed Python tool. This pin sniffer proof of concept tool listens for specific ABUS data packets on the correct 868 MHz radio frequency used for the wireless communication. Thus, when the alarm system is armed via the wireless control panel, the attacker can receive and decode the corresponding data packet in order to gain access to the used clear text pin code. As a matter of fact, the eavesdrop pin code can be used to disable the wireless alarm system in an unauthorized way.
The system is unset.
Besides using a pin code for arming and disarming the ABUS SegWest wireless alarm system, it is also possible to use an RFID token, also called proximity or chip key. For eavesdropping on the wireless communication, the attacker simply starts another developed Python tool. And now, when the RFID token is used with the wireless control device FUBE 50001, an attacker can receive and decode the corresponding data packet in order to gain access to the used proximity key ID.
The system is setting.
By knowing this ID, it is possible to create a cloned RFID token. Here, you can see the attacker's blue proximity key without having the correct programmed ID. But this can be changed by using a very user-friendly device from China that enables us to write arbitrary serial numbers to this RFID chip.
Please enter the card number 38059644445. Enter the correct card number is 38059644445. Write success.
The system is unset.
Success! The attacker could deactivate the wireless alarm system with a cloned RFID token using the sniffed proximity key ID in an unauthorized way. On this slide, you can see the output of our developed proof of concept tool for a successful pin code sniffing attack. The sixth and last kind of attack I want to show you in this talk is a spoofing attack. The targeted device in this attack is an ABUS SegWest hybrid module, which can be used to extend an ABUS SegWest wireless alarm system with wired components and to integrate the ABUS WAPLOX access control system. The issue here is that the used wireless communication of this hybrid module is missing security features regarding confidentiality and integrity. This enables an attacker to deactivate the wireless alarm system in an unauthorized manner, or to perform an authentication bypass attack regarding the WAPLOX access control system in a corresponding system configuration. In the next and final demo, a successful spoofing attack against an ABUS SegWest wireless alarm system with a hybrid module is demonstrated. Here you can see the used test setup with an ABUS SegWest wireless alarm system, a wireless motion detector, the hybrid module FUMO 50110 with a programmed switch, key switch configuration, and a yardstick 1 connected to the attacker system.
The system is unset. The system is setting.
In order to perform a spoofing attack against the insecure wireless communication, the attacker simply starts our developed Python tool. This software tool listens for specific status packets that are sent from the hybrid module to the wireless alarm panel at regular time intervals of about 2.5 minutes. When a packet containing a status message from the hybrid module is received, the attacker can launch a disarming attack using a spoofed radio packet
The system is unset.
and successfully disarm the wireless alarm system in an unauthorized way. Now it's time to draw some conclusions. In order to have a better picture, it is good to know the current patch status for the 8 security vulnerabilities I was talking about in the last few minutes. To my knowledge, up to now only the missing protection against replay attacks was fixed. All other described security vulnerabilities can still be found and exploited in the corresponding Arbus Sequest products. With that, I come to the conclusions that security products like wireless alarm systems may be more vulnerable to different types of radio-based attacks than you would probably first assume, that marketing claims regarding security features may just be that, marketing claims, that product certificates like VDS Home and EN 5131 Grade 2 may give a false sense of security, that some security vulnerabilities are hard or even impossible to fix in hardware products already in use, for example when no update functionality exists, or when there are compatibility issues concerning other devices you have to consider, and that so-called forever bugs may affect the security of a product until its end of life. Based on our research and my experience with wireless alarm systems, I therefore recommend to choose wireless alarm systems wisely, to perform a thorough online research before buying such a product, to reconsider your previous decision for using a wireless alarm system, to not have too much faith in product certificates and marketing claims, and finally to ask the manufacturer or vendor for further security testing beyond product certification and, this is very important, the scope of those tests if there were any. On the next 3 slides, I have put together several references to further information about different things regarding wireless alarm systems I have mentioned in this talk. So, this is it. I hope you've enjoyed my talk. Thank you very much for your attention. Do you have any questions?